time because you guys are here on time. So this is lesson 3.2 and 3.3. It's all about functions. And instead of essential questions, I'm switching over to I can statements. Okay, it's the same kind of general idea. These are the things you'll be able to do at the end of this lesson. So I can identify whether a relation is a function and explain why or why not. I can identify the domain and the range for a given function. I can explain the meaning of f of x for a value of x. I can use function notation to evaluate an equation. I can interpret a statement in function notation in terms of its context. So we'll look at lesson 3.2 first, which is understanding relations and functions. And that's our first two I can statements. The vocabulary that goes with this section, we have relation, a set of ordered pairs. Ordered pairs look like, in parentheses, x comma y, where x is the input value and y is the output value. A domain, all the possible inputs of a relation. So we're talking about all the possible x values. The range, all the possible outputs of a relation, all the y values. And now a function is a type of relation in which there's only one output for each input value. All functions are relations, because a relation just means it's a set of ordered pairs. But not all relations are functions, because functions are special types of relations. There has to be one output for each input. We're going to see what that looks like in terms of a graph and in a mapping diagram. Okay, and with the graphs, we're going to use something called the vertical line test. And that states that a relation is a function if and only if a vertical line, so remember vertical, that's straight up and down. Okay, horizontal is this way. Vertical line does not pass through more than one point on the graph of the relation. So you can take notes after we're done. You don't have to worry about trying to copy them down right now. Just pay attention and participate in the Pear Deck slides. And then this is being recorded and I'll post it through YouTube to our Week at a Glance so you can go back and rewatch it, okay? Functions can be represented in many ways. So there's different ways of viewing a function. And in this slide, you can see we have a table comparing gas and distance. We also have a graph comparing gas and distance. And then that last one, that's a mapping diagram. The two ovals with the arrows mapping gas to distance. And all three of these are representing the same function. All right, they're just shown differently. And so what we're going to do first is, what is the domain of this function? So even though it's represented three different ways, if I look at those, they're all using the same values as inputs and outputs. And we just talked about in the vocabulary back here, domain is of all possible inputs of a relation. X is the input value. So on your Pear Deck slide, it's a multiple choice slide. You're going to choose the domain. Okay, I'm going to give you a minute to do this. So I'm going to start a timer. You're going to go to your Pear Deck slide and choose which of those represent the domain of the function. Okay. Okay, so let's see what you guys thought was the domain. Looks like most of you picked B, 150, 240, 300. And then some of you picked A, now you're changing it. It's amazing how like seeing other people's answers will make you change your answer. As it stands right now, B is not the domain. The answer is not B. Okay, the domain, those are the inputs or the X values. So there is a picture of the graph, and along the bottom, we have 10. We have, it looks like maybe 16 and 17. Then we have 20. Okay, these are the inputs. These are the inputs. Those are the domain. So the correct answer is A. A. Right. But now I want to know, what is the range of this function? What is the range of this function? So you get a minute to do that. What is the range of this function? Help if I start the timer right. So 1 minute is multiple choice. Which of those show the range? Alrighty, so let's see what you guys came up with. Most of you picked B, 150, 240, and 300. And that's correct. So we look in the table, 150, 240, 240, 300. When you're listing out the range or the domain, if you have a repeated value, you don't need to repeat that value in your range and domain. You would just write it one time. And that's the same thing that's true about a mapping diagram. If you have a repeated value, you write it once, but then you're going to have 16 maps to 240 and 17 maps to 240. So that's why there's an arrow from 16 to 240 and 17 to 240. So this is a mapping diagram that's showing you all the ordered pairs. And there's 4 ordered pairs which are graphed here as well. Okay, so vertical line test. This is the next one we're going to look at. So I have 2 graphs. I have a graph of age and height, and there are some gray points plotted on it. And then I have a graph of gas and distance, and there are some pink points plotted on it. Those dashed in little lines are representing vertical lines for the vertical line test. And it's a test to tell if it's a function or not. So what we're looking for is for it to be a function, you can't ever have a vertical line that hits more than 1 point. So if there's only 1 point on each line, then it is a function. If anywhere a vertical line comes across more than one x value, there's a repeated x value, then it is not a function. And so that means that the one on the left, that is not a function. Right where the arrow is pointing to, there are 2 points that are stacked. They both have an x coordinate of 10. You can't have any repeated x values in a function, any repeated inputs like that, going to different outputs. For the graph on the right, because each pink dashed line is only touching 1 point ever and never more than 1 point, it is a function. So those are examples of a function, not a function, where you just have ordered pairs, but you could have continuous graphs like we have here. So on the left, I have a parabola, and it's the line that has the arrows on it. That is the graph. And then on the right, I have a parabola on its side, and the arrows represent the graph. Think about a vertical line and just moving that vertical line across your graph. So one of these is a function. Which one is a function? Thinking about what the vertical line test shows. Which one shows that I only ever touch one point at a time vertically? Which one shows there's no x value that maps to two different y values? So let me start the timer. I'm going to start it like halfway down because I first started sooner. So about 30 more seconds. You're going to click and drag the green thumbs up to which one is the function. Okay, so let's see what you guys are thinking. I think the left has more thumbs than the right. And if you're in the middle, I'm guessing you're not really sure what you want to put. Okay, but think about, and even if you have a pencil or a pen and you hold it up to your screen vertically, okay, straight up and down, and slide it across those pictures, which one only ever touches the graph once at a time, one point at a time vertically? It's the one on the left. This is our function over here. The function is on the left because there's only, it touches the graph at any x value. It doesn't repeat. Okay, they're all unique. Whereas over here, pretty much anywhere you draw a vertical line, you're constantly touching the graph at 2 points. Okay, except for right here at the halfway between 4 and 8, that's 6. Okay, so right there it touches once, but everything to the left of that is touching it twice everywhere. So the correct answer is the one on the left. It's the one on the left. All right, so identifying functions, we just looked at how you can do that. When you have a picture, like a graph, you can use the vertical line test. If you're given a representation of the values, like in a mapping diagram or a table or a list of ordered pairs, well, what we're looking for, if it's a function, is that there is only one output for each input. That means there's no repeated x values. One output for each input. If you look at the numbers for hours, this is the input side. And each of these values tell us the ordered pairs, the x coordinates of the ordered pairs. So we have 1, 11, that's an ordered pair. We have 2, 11, that's another ordered pair. The y value repeats, but when you're trying to figure out if it's a function, that's not important. What you care about are the inputs or the x values repeating. Another ordered pair is 3, 13, 4, 15, and 5, 17. Those are the 5 ordered pairs that make up the relation, which is also a function. Okay, this is a function. All right, you're going to find the function now. Again, you're going to drag your thumbs up. One of these is, one of these is not. Put your green thumbs up on the function. Which one is a function? Okay, so you should be back in your Pear Deck tab. Find the function. Have 12 of 19 responses. 10 more seconds. Okay, so let's go ahead and see what you guys thought. So on the right-hand side, it looks like 5 people think that is the function. On the left-hand side, 13 minus 5, the other 8 of you think this is the function. The 8 of you are correct, okay? The one on the left is, in fact, the function, because if you look at all the inputs, there's only one arrow coming out from each input. That's how you know it's a function. If I look at this graph, this mapping diagram, 5 maps to 2 and 5 maps to 4. So right there it fails, and it is not a function. I have a repeated x value. It says I have the ordered pair of 5, 2 and the ordered pair of 5, 4. I can't have a repeated x value like that. Also, it fails because of 11. I have the ordered pair 11, 6 and 11, 8. That is also not okay. So the one on the left is correct. Okay, so that's halfway through. We're done with lesson 3.2. This is lesson 3.3. These are the other 3 I can statements. We're talking about function notation now and modeling with functions. So the vocabulary that's necessary for this section is independent variable. That's the input of a function. That's your x. Dependent variable. That is the output of the function. That is your y. Function notation looks like that little f and then in parentheses the x, and you read that as y equals f of x. The function rule is an algebraic expression that defines a function. And in this class, on Monday, you guys were working with function rules in Desmos. Okay, so you have seen a little bit of function rules already. So function notation, we have the dependent variable is a function of the independent variable. Okay, so this is true, and if I want to see where this function notation comes from, well, the dependent variable we defined back a few slides, and the independent variable we defined as well, okay, or one slide back, excuse me. The independent variable is the input. Inputs are your x's. The dependent variable is the output. Outputs are your y's. You're trying to get that straight and memorize it. Input and independent both start with I, and we're talking about the x. So maybe if you have, it's kind of, you know, sometimes the best memory tricks are the ones that seem the dumbest, but you have 2 i's and then they would make an x. Okay, so I don't know, maybe I'll remember that, but so the dependent is the y, is a function of x, and then the word is, that's your equal sign. A function of is the f, and then of the variable x. So that's where y equals f of x comes from. And just kind of looking at it some more, you have a function machine like you had in Desmos, the guess my rule activity. Okay, we put an input, an x value, into the function, and then after something happens to it, you get an output out. That output is your y, which is also the f of x. They're the same exact thing. Function notation is just a fancy way of writing y. Yeah, you can think of it like that. All right, f of x is y. Y is f of x. They're the same. Right, f of x means the value of the function f at x and does not mean f multiplied by x, okay? Because I know, in math notation, if you have parentheses, it does typically mean multiplication. But when we're talking about function notation, we're not talking about multiplying f and x together. We're talking about a function of x. Okay, so let's look at some real problems using function notation and figuring stuff out in real life. So I'm going to do one with you, and then you guys are going to do one through the Pear Deck slides. Okay. So we're going to do 3 things with this situation. We're going to identify the independent and dependent variable. We're going to write a function in function notation. We're going to use the function to solve the problem. And here's our situation. Elmira earns $50 an hour. How much does she earn in 6 hours? All right, so first we're going to define the dependent variable and the independent variable. So the amount of money is dependent on the independent variable of the number of hours she's working. There's 2 variables. And if I want to write it in function notation, f of x, or f of whatever variable you use, we're going to set the number of hours, the independent variable, instead of x, but its independence, or x. Let's use h to represent hours. I could also have used x here. So f of h, or f of x, in this case it's h, equals, well, I have to multiply the amount of money with the number of hours worked. So I've taken a situation and turned it into a function where now this will work, for whatever amount of hours that I'm given. I can put it into the function and find out how much money that I'm making. And so in this specific case, we want to know for 6 hours. All right, so if h equals 6, f of 6 means it's your expression. You take out the variable and replace it with a 6. So I remove the h and the h, instead of using 6 and 6, because that's the number of hours that I'm trying to figure this out for. And this actually means 50 multiplied by 6, so that's 300. She earns $300 in 6 hours. That's a pretty good job. All right, this one you guys are going to do through Pear Deck. Again, we're going to go through the same 3 parts. We're going to identify independent and dependent variables on this slide. Next slide, we're going to write a function in function notation. And the last one, we're going to use a function to solve the problem. So our situation is Bruce owns a small grocery store and charges $5 per pound of candy. If a customer orders 10 pounds of candy, how much does Bruce charge the customer? So first we have to figure out what is the dependent variable and what is the independent variable. Okay, independent means we're talking about our x. Dependent means we're talking about our y. But what actual things in the situation would each one be? So you have a multiple choice question. You only have 2 options. Maybe 30 seconds to do this. You can go through and I want you to choose one of the 2 options. Giving you 30 seconds to do this. Do you think it's A or B? Yeah, it didn't change. It still says produce. I don't know why it did that. I tried to change it to candy, and I don't know, it still says produce. So that's probably just confusing you more than you need to be. But your 2 options of, hold on, get back to the right screen. So let me show you responses. I changed this on my side, but apparently didn't go through. Okay, so is the dependent variable the amount of money, and the independent variable the pounds of produce? It meant to say pounds of candy. Or is it B? Dependent is the pounds of candy, not produce, and independent is the amount of money. More of you say it's B. Amount of money is the dependent variable. Pounds of candy is the independent variable. Okay. You're going to write a function in function notation. This is another multiple choice. Let's give you the whole minute. Okay. Bruce owns a small grocery store and charges $5 per pound of candy. If a customer orders 10 pounds of candy, how much does Bruce charge the customer? So you're going to write a function rule in function notation that represents this situation. So you have 4 choices. Think about what you have to do with the number of pounds of candy purchased and what the cost is per pound. And then what do you do with those 2 values to get the total amount charged, where f of x is the total amount charged. That's our y, that's our dependent variable. Okay, so let's see here, showing your responses. Most of you thought it was A, f of x equals 5x. You were right. If we let x be our unknown for our independent variable, which is the pounds of candy, that's independent, that can fluctuate and change, okay? What we're going to do is, because he charges $5, that's set, we multiply the number of pounds with 5 to get the total amount of money that he's charging the customer, the total amount altogether. And then your last slide, your last interactive slide, you're going to use that function now, f of x equals 5x, to solve the problem. So this problem, our x, our pounds of candy, is 10. So what is he going to charge the customer using our function? Can you show, using the function, can you show f of x equals, and then substitute out your x value in place of the x? Let's give you a minute to do this. And it's a drawing one, so you could type it. Typing might be the easiest. Or you try drawing it, it's up to you. I think I'll give you more than a minute, because we do have plenty of time. I'll bump it back to a minute. So you should all be on your Pear Deck slide trying this. 23 more seconds. Okay. So let's see what we came up with. 9 of you responded. Can't hear me? Emily, you can't hear me? Oh man. Try unmuting your tab. Oh, it looks like she left and came back, so maybe that'll solve it. Can you hear me now, Emily? All right, so that doesn't really look like an answer. X equals 0, no. Let's see here. F of x equals 5x. And so they're trying to solve for x by isolating the x. That's an interesting take. That's what you would do if you're trying to solve an equation for x. This is not what you want to do in this situation. I'm not sure. Yes, it is $50 for 10 pounds, but what does that look like? I don't understand functions, so I appreciate your honesty. So I do want to show you what it would look like. And in order to show you what it would look like, okay, so I'm just going to open up a whiteboard screen real quick. And present, stop, present, entire screen right here, and share. Okay, so we know that we have f of x equals 5x. And I want to make sure everybody can see this. Yes, you can. Okay. Now, in the situation, we have 10 pounds of candy. And this is what our x is right now. So this is the x. So then I'm going to do f of, instead of x, I'm going to put 10. F of 10 equals 5 times, instead of x, this value goes right here. So I put a 10. And then that's where the 50 comes from. Okay? So let's come back to our, I'm going to show you the last slide. Okay. To find my Google Meet packet disappeared on me. There it is. All right. Present, stop, present, tab, Pear Deck. Okay, there you go. So it is $50. We're going to work more with functions. This week is kind of an introduction to functions. All right. And we're going to keep working with them next week as well. But what I want to offer to you right now, if anyone would like to stay on our Google Meet and work on your quiz because you didn't get a chance to do it yesterday or finish it yesterday, I want to give you that opportunity, okay? Otherwise, the meet is over and you're free to go.